Hi everyone, welcome to my channel. So in this video we will learn the section 6.9 integration using U-Substitution in AP calculus AB and BC. Let's see. So we have remember the chain rule, we have the chain rule like this, right? So d over dx equal to d over the derivative of a composite function f of g of x. You can see there is a outer function, there is a inner function. To find the derivative we use the chain rule, right? So that is we take the derivative of the outer function and then we take the derivative of the inner function and multiply. So we will get the derivative of this composite function. So in the similar way we have this piece. So the antiderivative of this one, that is the f prime of g of x times g of x dx. So to evaluate this integral we use a the inverse process, that is called the U substitution. If you take this one equal to u, then this integral becomes a simpler one, right? We can easy to work with this integral. So this is called a U substitution. So that is, so we have something similar when we take the antiderivative. It is called the U substitution. So look at the integral and think about the taking the derivative. If the derivative requires the chain rule, then the antiderivative will requires a U substitution, right? Okay. Now let's move to the first problem. So find the indefinite integral of this one. So the integral 3x minus 4 whole to the power 5 dx. Okay. Here you can see. So this is the integration. This is the integrand. You can see the integrand. So there are the two functions. The inner function is 3x minus 4 and the outer function is x to the power 5, right? So let's choose this inner function. This one 3x minus 4 is u. Okay, so let u equal to 3x minus 4. Then du is, you can see, so 3 times, so take the derivative, that is the 3 times dx minus the constant derivative is 0, which is 3 dx. Okay, and solve for dx, you will see du over 3 equal to dx. Okay, so now let it aside. Now this integral becomes, we have the integral 3x minus 4 whole power 5 dx. So this integral becomes integral, so 3x minus 5 equal to, which is 4. Sorry, this is u, right? That is the u to the power 5 and the dx equal to du over 3. Okay, now you can factor out this 1/3. So 1/3 integral u power 5 du. You can now see this integral becomes very simpler one, right? So that is the 1/3. So the integration of u to the power 5 is, which is u to the power 5 plus 1 over 5 plus 1 plus c, which is 1/3. So which one is e to the power 6 over 6 plus c, and this is equal to, you can see the 1/6 can be factored it out. So it becomes 1/3 times 1/6, that is the 1/18, and u power 6 plus c. And so since our original variable x, so we have to back substitute to the original variable, that is 1/8. So u equal to 3x minus 4, right? So you can back substitute, that is the 3x minus 4 whole to the power 6 plus c. So this is the final answer, the integration of this integral. Now let's move to the next problem. So we have the integration, we have, so integral 6x square x cube plus 5 whole to the power 5. You can see the derivative of this one, the x cube plus 4 is available right here. So there is just some information, the derivative is available here. Okay, so you can choose the u equal to x cube plus 4 here. Then du equal to, which is 3x square dx, because the constant derivative is 0. Now solve this for x dx, that is the du over 3x square equal to dx. Okay, so let this aside. Now this integral becomes the integral, so 6x square x cube plus 4, that is the x cube plus 4 equal to u to the power 5, and dx is du over 3x square. You can see here the x square get cancelled, and 3 ones and 3 twos, which is 2 times u power 5 du. You can factor the 2, that is the integral u power 5 du. So this is equal to 2 times the integration of u to the power 5 is, which is e to the power 6 over 6 plus c, and finally we come back to the original variable. So substitute u equal to x plus 4, x cube plus 4 whole power 6 over 6 plus c, here 2 ones 2 threes, so this one is x cube plus 4 whole power 6 over 3 plus c. So this is the integration of the given integral using the substitution. Now let's see the next problem. So we have integration of square root of x minus 1 whole square over square root of x. Okay, let's see. You can see the square root of x minus 1, the derivative is 1 over 2 root x. So you can choose this u equal to square root of x minus 1. Then du equal to the square root of x derivative is 1 over 2 root x, and the derivative of this constant is 0, that is dx. So therefore dx equal to, you can do the cross multiplication here, so that is 2 root x du. Okay, so let this aside. So now you can rewrite this integral as a, so square root of x minus 1 is u whole square over root x times dx. So dx can be written as 2 root x du. Here you can see the root x get cancelled, so that is you will get to 2 times u square with respect to du. So you can factor out the 2 also, so that is the u square du. Now 2, the integration of u square is, which is u cube over 3 plus c, and this one you can factor out the 3, that is the 2 third u cube, and u cube equal to square root of x minus 1 whole cube plus c. So this is the final answer of this integral. Now let's solve the next problem. Integral. So we have the integral sin x e to the cos x dx. You can see the derivative of the cos x is available here. So you can choose the u equal to cos x. Then du equal to the derivative of cos x is negative sin x dx. Then solve this equation for the dx. So that is the dx equal to du over negative sin x. Okay, let's keep it aside. Now rewrite this integral. Integral sin x times e power cos x is e power u, and dx equal to du over negative sin x. Now you can see the sin x get cancelled, and this becomes integral. We have the negative here, then you factor out the negative, integral e power u du. So that is the negative, the integration of e power u is just u power u plus c, and negative e power back substitute is the u, that is the u equal to cos x plus c. So therefore the integration is negative e power cos x plus c. Now let's move to the next one. We have the cot 3x. Okay, so cot is the outer function, 3x is the inner function. The derivative of the inner function is available here, so choose u equal to 3x. Then du equal to 3 dx. Okay, then dx equal to du over 3. Dividing both sides by 3, you will get this one. Okay, now let's move it aside. So this one equal to, so integral cot 3x can be written as integral cot 3x is u and dx equal to du over 3. So now factor the 1/3, that is the integral 1/3 integration of cot u du. You can see the 1/3, the integration of cot u is, so you can rewrite the cot u as a cos u over sin u du. That is the 1/3. So here we have a one formula. If the derivative of the denominator is available in the numerator, then we can written as the integration is ln of absolute value of the denominator sin u plus c. So that is the 1/3 ln absolute value of sin u, and u equal to sin 3x plus c. So this is the integration. Let's solve the next problem here. So we have integral x over square root of x plus 1 dx. Okay, let's choose u equal to x plus 1 here. So u equal to x plus 1, then du equal to dx. Okay, so here if u equal to x plus 1, then x equal to u minus 1, right? Subtracting both side 1. So now let's use this. So this integral can be written as, so x can be written as u minus 1, and the square root of x plus 1 is u, and dx equal to du. So this can be written as, so u over square root of u, that is the u power 1/2 minus 1 over u power 1/2 du. So this one is integral u over u power 1/2 is u power 1/2 minus, so this one is u power negative 1/2 du. So this is equal to the integration of u power 1/2 is, which is the u power 1/2 plus 1, that is the 3/2 u over 3/2, which we can written as a 2/3 minus u power negative 1/2, the integration is u power negative 1/2 plus 1, so that is the u power positive 1/2 over positive 1/2 can be written as 2 plus c. So this one 2/3, the u equal to x plus 1, 3/2 minus 2 times x plus 1, 1/2 plus c. Now let's solve this problem. So we have integral 1 over square root 1 minus 4x square dx. Okay. Let's see. Let's rewrite this integral as the integral 1 over square root 4x can be written as 2x whole square and dx. Now let's see. So we have the this is the derivative of the inverse sine function, but there is a inner function 2x. So we can substitute u equal to 2x here. Then du equal to 2 dx, or du over 2 equal to dx. So let's see this side. So now rewrite this integral as a integral 1 over square root 2x can be written as 1 minus u square, and dx equal to du over 2. So that is the 1 half. You can see 1 over square root 1 minus u square with respect to du, and this is 1 half. So this is the integration of sine inverse u plus c. That is the 1 half sine inverse and u equal to 2x plus c. So this is the integration of this integral. Let's see the next problem. Evaluate the definite integral. So here you can see this is a definite integral, and the derivative of this inner function is there available outside. So you can choose u equal to t cube plus 1, then du equal to, so t cube derivative is 3t square and constant derivative is 0, that is the dt, and dt equal to du over 3t square equal to dt. Okay, also we have the limits. When t equal to 0, the u equal to t cube plus 1, that is the 0 cube plus 1, which is 1, and t equal to 2, then u equal to 2 cube plus 1, which is 2 cube is 8, 8 plus 1 is 9. So the limits are 1 to 9. So now let's rewrite this integral. Let's rewrite this integral as the integral limits are, so 0 becomes 1 and 2 becomes 9, and t square, and the square root of t cube plus 1 is just u, and dt equal to du over 3t square. Now you can see t square and t square get cancelled, so this becomes 1/3 integral 1 to 9 root u du. Now you can find the integral. So this can be written as a rational exponent, that is the u power 1 half, and the integration of u power 1 half is u power 3 half. Okay, that is the integration is u power 3 half over 3 half, and the limits are 1 to 9, and this one is 3 half can be written as a 2/3. So that is the when you flip this fraction, that is a 2/3, and the denominator 3 times 3 becomes 9, and this one is u power 3 half over limits 1 to 9. So this is the 2/9. So this one is 9, so 9 3 half minus 1 power 3 half. So this becomes, this is the 2/9, and 9 becomes, so 9 can be written as 3 square, the 3 square and 1 half get cancelled, so that is the 3, and 3 cube is 27, minus 1 power anything is just 1, so this is equal to 27 minus 1 is 26, so 26 times 2, so we have the 26 times 2, that is the 26 times 2 is 52 over 9. So this is the integration. Moving to the next question. So we have the inside the square root sin x and cos x is there. So you can see the derivative of sin x is cos x is available outside. So you can choose the u equal to sin x. U equal to sin x, then du equal to the derivative of the sin x is cos x and dx. Okay, and the limits are when x equal to 0, then u equal to sine 0. The sine 0 is still 0, and x equal to pi over 2, u equal to sine pi over 2. So sine pi over 2 is just 1. So the new limits are 0 to 1. So this integral becomes integral 0 becomes 0 and pi over 2 becomes 1, and we have the cos x and the square root sin x can be written as u and dx can be written as cos x dx. Okay, here the dx can be written as du over cos x equal to dx. So dx can be written as du over cos x. Now cos x get cancelled. So this becomes integral 0 to 1 square root u du. So which is the integration of square root u is u power 3 half over 3 half, and the limits are 0 to 1. So that is the 2/3 u power 3 half and limits are 0 to 1. So that is just 2/3. When you substitute the upper limit, we have the 1 and the lower limit 0. We have the 2/3. Okay. And the next problems. So we have find the indefinite integral x square over 1 plus x square whole square 1 plus x cube whole square dx. Okay, here you can see the derivative of the inside function is available outside. So you can choose the u equal to 1 plus x square. Then du equal to the derivative of 1 is 0 and the derivative of x square is 2x and dx. So dx equal to du over 2x equal to dx. Okay. Now this integral becomes so x square over 1 plus x cube 1 plus sorry. Okay. So let's move this problem. So we have the integral x square over 1 plus x cube whole square dx. So that is, here you can see the derivative of this inside n plus x cube is available in the outside. So you can choose the u equal to 1 plus x cube. Then du equal to the derivative of 1 is 0 and the derivative of 3x cube is 3x square dx. So from this du over, so dividing both sides 3x square, you will get dx. So let's see, let's keep it aside. Now this integral becomes integral the x square is x square and 1 plus x cube can be written as u whole square and dx can be written as du over 3x square. Now this x square and x square get cancelled. Here 1/3 is there, the 1/3 can be factored it out from the integral, and this is 1 over u square. This can be written as u power negative 2 du, and this is 1/3. So u power negative 2, the integration is u power negative 2 plus 1 over negative 2 plus 1, that is the u power negative 1 over negative 1 plus c. which is 1/3 negative 1 over u plus c. So that is the negative 1 over 3u plus c. Okay, and now you can substitute back to the original variable. So u equal to 1 plus x cube, that is the 1/3 1 plus x cube plus c. So this is the integration of the given integral. Now move to the next question. So we have the cos root x over root x. Okay, you can see the root x here, the inner function root x, so the derivative is also, the root x is available outside, so you can choose the u equal to root x here. Then du equal to, the derivative of root x is 1 over 2 root x and dx. And dx equal to this one 2 root x, du equal to dx. Now let's move this side, and this integral becomes integral cos root x can be written as u over this root x times dx can be written as 2 root x du. You can see this root x and root x get cancelled, so this becomes 2 integral cos u du, and this is integral, so the integration of cos u is sin u plus c, and this is 2 sin, back to the original variable u equal to root x plus c. So this is the integration. What is the next problem? So we have the derivative of the denominator is cos square x. Okay, so let's see. Okay, here you can see, let's use u equal to cos x. So then this becomes du equal to sin x dx, right? Then dx equal to du over sin x. Let's keep it aside, and this becomes integral, so sin x over 1 plus cos x is u square, and dx equal to du over sin x, and sin x get cancelled, and this is equal to integral 1 over 1 plus u square du, and you can see this is a inverse tangent of u. Okay, this is the tan inverse u plus c. So that is the tan inverse u equal to cos x plus c. So this is the integration. Let's move to the next problem. So first you can rewrite this integral as a integral 1 over square root 1 minus 3x whole square dx, because this is a sine inverse, you can see. So this is like a sine inverse function, the antiderivative, and we can use this part as inner function as a u. So this is the u equal to 3x, then du equal to 3 dx, or du over 3 equal to dx. Okay, now this integral becomes integral 1 over square root 1 minus 3ux is just u square, then dx is du over 3. So now this is the 1/3 integral 1 over square root 1 minus u square du. So this is 1/3. So this is the integration of sine inverse. So that is the sine inverse u plus c. So this is the 1/3 sine inverse of, and u equal to 3x plus c. Let's move to the next problem. So here you can see integration of e power x sine e power x. You can see the sine and e power x. The inner function e power x, that is the derivative is available outside. So you can choose the u equal to e power x. Then the derivative is also e power x dx. So therefore du over e power x equal to dx. So let's put aside. So this now this integral becomes integral e power x, and this and e power x is u, right? Okay, e power x or u power x equal to u, and sine u, and dx equal to du over e power x. Okay, e power x equal to u, here you can leave it as e power x. So here the e power x and e power x get cancelled, and this becomes integral e power x, that is the sine u du, and the integration of sine u is negative cos u plus c, that is the negative cos, and u equal to e to the x plus c. This is the integration. Let's move to the next problem. So we have the integral tan x cos x dx. So this integral can be written as, so tan x can be written as a sin x over cos x, and we have the cos x dx. Here the cos x get cancelled. So this integral becomes sin x dx, and the integration of the sin x is negative cos x plus c. So this is the integration. Here this problem, we can see the derivative of the tan x is secant square x, so that is available here. So you can choose the u equal to tan x, then du equal to secant square x dx, or dx equal to du over secant square x. Let's keep it aside. So this integral becomes, so secant square x over, so in square root tan x equal to u, and dx equal to du over secant square x. Now this secant squared x get cancelled, and this integral becomes integral 1 over square root u, that is the u power negative 1 half du. So therefore u power negative 1 half integration is u power positive 1 half over positive 1 half plus c, or 2 root u plus c, that is the 2 root u equal to tan x plus c. So this is the integration of the given integral. Now let's move to the next one. We have integral x dx, and we have the square root of 1 minus x square. For this integral, let's choose u equal to 1 minus x square. Then du equal to, the derivative of the constant is 0, then the derivative of the negative x square is negative 2x dx. Then du over negative 2x equal to dx. Okay, let's keep it aside. Now this integral becomes integral x dx, x, and dx can be written as du over negative 2x over square root of 1 minus x square equal to u. You can see here the x and x get cancelled. The negative 1 half can be factored out here. So that is the negative 1 half integral 1 over square root u du. And this one is 1 half. So this can be written as a rational exponent to u power 1 half, and it is moved to the numerator, that becomes u power negative 1 half du. So that is the negative 1 half, and the integration of the u power negative 1 half is u power negative 1 half plus 1, that is the u power positive 1 half over positive 1 half, that is the 2 times so u power positive 1 half, that is the square root u. Okay, and plus c. Now this negative 2 and 2 get cancelled, so that is the negative 1 square root and u equal to 1 minus x square plus c. So that is the negative square root 1 minus x square plus c. So this is the integration of the given integral. Now let's move to the next one. So integral of ln of x whole power 5 over x dx. You can see the derivative of the ln x is 1 over x. So you choose the u equal to ln x. Then du is 1 over x dx. Then dx equal to x times du. Okay. So let's move this aside. So now rewrite this integral. Integral ln of x is u to the power 5 over x times dx equal to x du. Here x get cancelled, so this integral becomes integral u to the 5 du, and the integration of u to the 5 is u to the power 5 plus 1 over 5 plus 1, that is the u to the power 6 over 6 plus c, and u power u equal to ln of x. So ln of x all to the power 6 over 6 plus c. So this is the integral. Okay. Now let's move to the next problem. So we have the integral of 1 over 25 x square plus 1 dx. So let's rewrite this integral as a integral 1 over 1 plus 25 x square can be written as 5x whole square dx. You can see this is something like integration of the inverse tangent function. So but there is a, instead of x we have the 5x. So let's choose u equal to 5x. Then du is 5 times dx. Then dx equal to du over 5. So let's keep it aside. So now this integral becomes 1 over 1 plus 5x is the u square, then dx equal to du over 5. So we can factor out the 5, 1/5, that is the 1 over 1 plus u square du, that is the 1/5. So this is the tan inverse u plus c, that is 1/5 tan inverse, and u equal to 5x plus c. So this is the integration of the given integral. Let's say this problem. So we have the integral of 2x plus 5 and x square plus 5x whole to the power 7 dx. You can see the derivative of this function is available outside. So you can choose the u equal to x square plus 5x. Then du is 2x plus 5 and dx. So the dx is du over 2x plus 5. Now let's keep it aside. So this integral becomes integral 2x plus 5 times, this one is x square plus 5x is u power 7, and dx equal to du over 2x plus 5. Here the 2x plus 5 and 2x plus 5 get cancelled. So this becomes integral u to power 7 du. So the integration of u power 7 is, that is the u power 8 over 8 plus c, and u power 8 back substitute to the original variable. So u equal to x square plus 5x whole power 8 over 8 plus c. So this is the integration of the given integral. and we have, so integral e power x dx, e power x over 4 minus e power x dx. So here let's choose u equal to 4 minus e power x, then du is, the derivative of 4 is 0, and the derivative of negative e power x is negative e power x dx. Then dx equal to du over e power negative x. Okay, so let's keep it aside. Then this integral becomes integral e power x over 4 minus e power x equal to u, and dx equal to du over minus e to power negative x. Here e power x and e power x get cancelled, so we can factor out the negative, that is the integral 1 over u du, and you can see this is the ln of absolute value of u, and this one is ln of, back to the original variable, u equal to 4 minus e power x, e to the x plus x. So this is the integration. And let's see this problem. So we have integral 0 to pi over 2 sine 2x dx. So this problem can be written as, or you can choose the u equal to 2x, then du equal to 2 dx, right? Then dx equal to du over 2. So this becomes, also we have the limits. So when x is 0, then u equal to 2x, that is a 2 times 0, which is 0, and x equal to pi over 2, and u equal to 2x, that is a 2 times pi over 2, which is pi. Okay, let's okay, now let's rewrite this integral. So integral 0 becomes 0, and the upper limit pi over 2 becomes pi, and the sine 2x is u, and the dx is du over 2. So that is how we can factor out the 1 half. So 0 to pi sine u du, and the integration of the sine u is, which is negative cos u, and 0 to pi, that is the 1 half. So you can substitute the limits. So these limits are the u limits, so you can substitute here. So that is the negative cos pi minus of minus plus cos 0, which is 1 half minus cos pi is negative 1 plus cos 0 is 1, which is 1 half negative of negative positive 1 plus positive 1, which is 2. So therefore 2 get cancelled, which is 1. And we have the integral 0 to 4 1 over square root of 2x plus 1 dx. So let's choose u equal to 2x plus 1. Then du is 2 times dx, and the constant derivative is 0. So that is the du over 2 equal to dx. And we have the limits. When x equal to 0, then u is 2 times 0 plus 1. That is the 2 times 0 plus 1, which is 1. And x equal to 4, and u is 2 times 4 plus 1, which is 2 times 4 is 8, 8 plus 1 is 9. So therefore, so this integral becomes integral, so the lower limit 0 becomes 1, and the upper limit 4 becomes 9. 1 over square root of 2x plus 1 becomes u, and dx is du over 2. So this is you can factor out the 1 half integral 1 to 9 1 over root u du. So this is the 1 half integral 1 to 9. So this is the 1 over u power 1 half du. That is the 1 half. So this is the integral 1 to 9 u power negative 1 half du. Then 1 half. So you can see the integration of the u power negative 1 half is u power negative 1 half plus 1, which is u power 1 half. That is the root u over 1 half, that is the 2 root u. Okay, let's write the one step here. The integration of u power 1 half is u power 1 half plus 1, that is the 1 half over 1 half, which 1 half, and the limits are 1 to 9. So this becomes 1 half. So this 1 half becomes 2, and u power 1 half 1 to 9, which is 2 to get cancelled. So u power 1 half is 9 power 1 half minus 1 power 1 half, which is 3 minus 1, which is 2. So therefore the definite integral is 2. So let's see this problem. So we have the tan x and its derivative is also available here. So let's use u equal to tan x. Then du is secant square x dx, or du over secant square x equal to dx. Okay, so that is when let's use the change the limits. So when x equal to negative 5 over 4, what is u? U equal to tan negative 5 over 4. So tan negative 5 over 4 is negative 1. When x equal to 0, u equal to tan 0, that is the tan 0 is 0. So therefore so we have this integral becomes integral, the lower limit negative 5 over 4 becomes negative 1, and the upper limit 0 becomes 0, and tan x is u, and secant square x, and dx is du over secant square x. Here the secant square x get cancelled, so this integral becomes negative 1 to 0 u du, which is u square over 2 minus 1 to 0, which is 0 square over 2 minus, so minus 1 whole square over 2, which is 0 minus 1 half, which is negative 1 half. So therefore the integration is negative 1 half. Okay, let's rewrite this problem. So integral 0 to pi over 8. So secant 2x. So secant 2x can be written as 1 over cos 2x, and tan 2x can be written as sin 2x over cos 2x and dx. So that is integral 0 to pi over 8. So this is the sin 2x over cos square 2x. Okay, now you can see the cos square 2x, the derivative is available in the outside. So let's choose u equal to cos 2x, then du is the derivative of cos 2x is negative sin 2x, and give the chain rule, the derivative of the inner function is, which is 2 dx. So therefore the dx equal to du over negative 2 sin 2x. Okay, and the limits we have, so at x equal to 0, then u equal to cos 2 times 0, which is cos 0 is 1. and x equal to pi over 8, then u equal to cos 2 times pi over 8, which is pi over 4, that is the cos pi over 4, which is root 2 over 2. Okay, so let's keep it aside. Now, so this integral becomes, the lower limit becomes 0 becomes 1, and the upper limit becomes root 2 over 2, and the sine 2x over cos square 2x is, this is the u square, and the dx is du over negative 2 times sine 2x. So here the sine 2x get cancelled. Here you can factor out the negative 1 half. So negative 1 half integral 1 to root 2 over 2 and 1 over u square, that can be written as u power negative 2 du. And this one is 1 over root 2, and the u square, the integration is u power negative 2 plus 1, which is u power negative 1 over negative 1. And the limits are 1 to root 2 over 2. So which is, you can factor out the negative here. So that is the 1 half, and u power negative 1 can be written as 1 over u, and the limits are 1 to root 2 over 2. So here, so 1 half, so here 1 over u, that is the 1 over root 2 over 2 minus 1 over 1, which is 1 half. So this is a complex fraction. We can rewrite this as a 2 over root 2 minus 1, and distribute the 2. So you will get the 2 to get cancelled. This is the 1 over root 2 minus 1 half. So this is the definite integral. And we have the, so the integral 1 to e ln of x over x dx. So we have the ln of x. So the integration of, let's use the u equal to ln x here. Then du is 1 over x dx. Du is 1 over x dx, or dx equal to, can do the cross multiplication, x times du. Okay, and here you can see the limits are, when x equal to 1, then u equal to ln of 1, which is 0, and the x equal to e, and u becomes ln of e, since ln and exponential are inverse to each other, which is 1. So therefore, so this integral becomes, so the lower limit 1 becomes 0, the upper limit e becomes 1, and ln x is u over x times dx equal to x times du. Now the x get cancelled, so this is integral 0 to 1 u du. So that is the integration of u is u square over 2, and the limits are 0 to 1. So that is the 1 square over 2 minus 0 square over 2, which is 1 half. So this is the definite integral is 1 half. And we have the, so we have u equal to, since this the derivative is available in the numerator, so let's use u equal to x cube plus 3x square plus 4. Then du is which is 3x square plus 3x square derivative is, which is the 6x, and dx. Okay, and you can see du equal to, you can factor out the 3 here, so that is x square plus 2x and dx, and dx equal to, divide both sides by 3 times x square plus 2x, you will get du over 3 times x square plus 2x. Okay, and the limits are, when x equal to 0, then u equal to, so 0 cube which is 0, and 3 times 0 square which is 0, then 4 we have the 4, and x equal to 1, we have u equal to 1 cube plus 3 times 1 square plus 4, which is 1 cube is 1, and 1 plus 1 plus 3 times 1 square is just 3, plus 4 which is 1 plus 3, 4, 4 plus 4 which is 8. Okay, so these are the limits. So now this integral becomes, so this integral becomes, so the lower limits 0 becomes 4, and the upper limits 1 becomes 8, and we have the x square plus 2x over, so this one is the cube root of u, and dx equal to du over 3 times x square plus 2x. Now you can see this x square plus 2x and x square plus 2x get cancelled. So that becomes, so you can factor the 1/3 and integral 4 to 8. This is the du. So we have the cube root u, 1 over cube root u du. So now 1/3. So this can be written as a rational exponent 1/3, and move to the numerator. This becomes, so 4 to 8 u power negative 1/3 du, and that is the 1/3. So u power negative 1/3 can be written as u power negative 1/3 plus 1, that is the 1/3 or negative 1/3 plus 3/3, that is the 2/3. So u power 2/3 over 2/3, the over 2/3 becomes 3/2. Okay, and the limits are 4 to 8. Here you can see the 3 and 3 get cancelled, so this becomes 1/2, and substituting the limits, so 8 2/3 minus 4 2/3. So 8 2/3 is, this can be written as a 2 cube. So cube and 1/3 get cancelled, that is the 2 squared. That is the 1/2, 2 squared is, which is 4. And here the 4 can be written as, so this can be written as, you can leave it as it is, 4 2/3. So this is the definite integral. And then we have, so 2 sin x plus sin 2x dx, the integral 0 to 2 pi. So first let's rewrite this integral 0 to 2 pi 2 sin x, and the sin 2x can be written as 2 sin x cos x and dx. So that is, we can factor out the 2 sin x here, so that is integral 0 to pi, we can factor out the 2 sin x, so which is 1 plus cos x dx. Now you can see the cos x derivative is sin x available here, so you can choose the u equal to 1 plus cos x, then du is, which is negative sin x dx, or dx equal to du over negative sin x, and the limits are, when x equal to 0, the u becomes equal to 1 plus cos x, that is the 1 plus cos 0. Cos 0 is 1, that is the 1 plus 1, which is 2. And x equal to pi, that is the u equal to 1 plus cos pi. That is the 1 plus cos pi is negative 1, which is 1 plus negative 1 is 0. So therefore, so this integral can be written as, so this integral can be written as, the lower limit 0 becomes 2, and the upper limit pi becomes 0, and 2 sin x, and 1 plus cos x is u, and dx is du over negative sin x. And you can see this sin x and this sin x get cancelled. So that negative 2 can be factored it out from the integral, that is the 2 to 0 u du. That is the negative 2. The integration of u is u square over 2 and 2 to 0. So you can factor out the 2 here, that is the 2 to get cancelled. So that is the negative u square 2 to 0, which is negative. So 0 squared minus 2 squared, which is, so negative of 0 squared minus 2 squared, which is negative 4. So negative of negative 4, that is the positive 4. So we have the answer positive 4. Let's see. So we have the integral 0 to k x power x square plus 6 dx equal to 1 over 1 half ln of ln 6, where k is greater than 0. We have to find the k value. So let's evaluate this integral. So let's use the u equal to x square plus 6 here, and du equal to 2x dx. Then dx becomes du over 2x. And the limits are, when x equal to 0, u equal to 0 squared plus 6, which is 6. And the x equal to k, the upper limit, u equal to k squared plus 6. Okay, so now this integral becomes, integral, when lower limit is 0, u equal to 6, and the upper limit k, we have the k square plus 6, and we have the x over u, and the dx equal to du over 2x. Now the x get cancelled, so this is equal to, you can factor out the 1 half, and integral 6 to k square plus 6 1 over u du. So which is 1 half. So 1 over u du is ln of absolute value of u, and the limits are 6 to k square plus 6. Okay, so which is, so we have the 1 half, substitute the upper limit, that is the ln of k square plus 6 minus ln of 6. So this is the integral, but this integral equal to 1 half of ln 6. Okay, so let's solve this problem. So we have, so dividing both side with 1 half, or multiplying both side, you will get 1 half get cancelled. And here, so this is the ln of a minus ln of b, which is ln of a over b. So we can rewrite this as a k square plus 6 over 6, which is equal to ln 6. And apply the inverse logarithm, you will get ln get cancelled, and this is equal to k square plus 6 over 6, which is equal to 6. And we have, so cross multiplication, k square plus 6 equal to 36, and k square equal to 36 minus 6. 36 minus 6, that is a 30, or k equal to plus or minus 30, root 30. But in the problem which is given k equal to positive only, so we can discard the negative value, so that is the k equal to root 30. So the option B is correct. And finally, so we have the function f is continuous, and integral 4 to 19 f of u d is 19. So what is the value of integral 1 to 4 x f of x square plus 3 dx? Okay, here you can choose the inner function x square plus 3. The outer function is x, so we can choose the u equal to u equal to u equal to x square plus 3. Then du is, that is a 2x dx, or dx equal to du over 2x, right? So, and the limits are, when x equal to 1, then u becomes u equal to x square plus 2. So 1 square plus 3, sorry, u equal to 1 x square plus 3. So u equal to, at 1 square plus 3, which is 4. And x equal to 4, we have u equal to which is the 4 square plus 3, which is 16 plus 3, which is 19. So this integral becomes okay. So this integral becomes, when x equal to 1, u is 4, and x equal to 4, u is 19, and x times f of u, and dx equal to du over 2x. And now this x and x get cancelled, and this is equal to, so you can factor out the 1 half here. So 1 half integral 4 to 19 f of u and du. And you can see, so this is given in the question, integral 4 to 19 f of u du is 10. So that is the 10. So that is equal to 5. So therefore the correct option is B. So this is this problem. Now let's see the one last problem. Here we can rewrite this integral as, so let's factor out the 16 from 16 here, that is the, when you factor out the 16, which is 1 minus x square over 16, okay, and dx. And you can see this can be written as a 1/4 1 minus square root 1 minus x over 4 whole square, and dx, or 1/4 integral square root of 1 minus x power 4 whole square dx. Okay, so let's use the u substitution here. Let's use the u equal to x power 4, x over 4. So u equal to x over 4, then du is dx over 4, or dx is 4 times du. Okay, so now we can rewrite this integral as a, so 1/4 integral 1 over square root of 1 minus u square, and the dx can be written as 4 times du. Now you can see this 4 and 4 get cancelled, and this is equal to integral 1 over 1 minus u square du. So which is sine inverse u plus c, and sine inverse, and what is u? U equal to x over 4 plus c. Okay, so therefore the correct option is, so this one is sine inverse x over plus c. So this is the sine inverse x over 4 plus c. This one is the correct option. Hope this video is helpful to you. If this video helpful, please do like, share and subscribe. Thank you so much for watching this video.